Namaste, welcome to Ganapati Maths classes. Today we will discuss one important concept, that is greatest integer of a function. This is very useful in Jee Mains. First of all, I will explain the concept of the greatest integer function. For x belongs to R, x is any real number, and there exist n belongs to Z such that n less than or equal to x less than n plus 1. X is any real number and n belongs to Z. Satisfies this condition, n less than or equal to x less than n plus 1. Then this n is called greatest integer of x. Now symbolically should write now square bracket x, step x. This is read as step x is equal to n. Step x is equal to n. Why I given step x we will discuss through graph. Okay. Now step x equal to n. Very clear from definition we observed here. X is lie between two consecutive integers. For example, x is equal to 1.5 I taken. Then what about step x is equal to what? Step 1.5 is equal to 1. Why? Because very clear 1 is lie between 1 and 2. 1 less than 1.5 less than 2. Now comparing with definition, what is n here? 1. That's why step 1.5 is 1. That's why the given number we are observing lie between two consecutive integers when x is non-integer. Observe. For example, one more, x is equal to 1.999. Then step 1.99 is also 1. Why? Because this number also lie between 1 and 2. Okay, one more example I will give. Step 3.5. Very clear, 3.5 lie between 3 and 4. So that's why by comparing with condition, step 3.5 is 3. Okay, very clear. Step 3.9999 also 3. Why? Because this number also lie between 3 and 4. Now I go for negative number, one more observed here. X is equal to minus 1.5 I taken. X is equal to minus 1.5. What about step minus 1.5? Now we can observing the given number lie between two consecutive integers. What are they? So minus 1.5 very clear lie between minus 2 less than minus 1.5 is less than minus 1. So very clear, step of minus 1.5 is comparing with the condition minus 2. Okay, again minus 3.9 is equal to. Very clear, this number is lie between minus 4 and minus 3. So minus 4. Okay, I taken all x values are non-integers. What about step of an integer? So, for example, step 2 is equal to 2. Step of minus 3 is equal to minus 3. Why? Because observing the condition, n is less than or equal to x. Okay, is equal to n is equal to x when x is an integer. The condition observing. X is non-integer, that number, step of that number lie between two consecutive integers. Suppose here x is integer, step of x is itself. Step x is equal to x. That's why now we should generalize now. Step x is equal to x for x belongs to Z. Okay. Now through graph I will explain now. Observe. I'll take points 0, 1, 2, 3, 4 and so on up to infinity. Minus 1, minus 2, minus 3, minus 4 and so on, minus infinity. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4 and so on. I will take let y is equal to step x or f of x is equal to step x. Very clear. What about domain of this function? According to definition, for any x belongs to R. That's why domain of f is what? Set of all real numbers. As step x is always, from definition observed here, step x is equal to what? N. What is n here? Integer. That's why very clear the range of the function, the range of the step function is what? Set of integers. This point remember. Okay. Now observing the graph now. Now very clear. Suppose x is equal to 0, then step 0, 0. Now x is equal to, for example, 0.1. Step 0.1, 0. Why? Because 0.1 lie between 0 and 1. Again, not only 0.1, up to 0.9999 also. Approaches to 1. Every value connected or related with 0. That's where this is the here. But the graph is discontinuous at x is equal to 1. Why? Because step 1 is equal to what? 1. That's why the graph is discontinuous at this point. Okay, step 1 is equal to what? 1. Step 1.1, 1. Step 1.2, 1. Step 1.9, 1. Step 1.999 approaches to 2, also 1. But the graph is discontinuous at x is equal to 2. Why? Because step 2 value 2. Step 2, 2. Again next 2.1. Step 2.1, 2. Step 2.2, 2 and so on up to 2.999, that is approaches to 3, also 2. That's why we should draw like this. But the graph is discontinuous at x is equal to 3. Why? Because step 3 value 3. Now similarly you should draw, remind me. Like that. Now you go for negative side. Negative side of the x-axis. Okay, same concept you can observe now. Step minus 0.5. Minus 0.5 is lie between minus 1 and 0. That's why step minus 0.5, minus 1. Step minus 0.6, minus 1. Okay, that's why observing here. The graph is discontinuous at x equal to 0. Okay, step 0. Step 0 is 0. And here, up to here, so at x equal to minus 1, step minus 1 value, minus 1. And also the graph is discontinuous at this point. Okay, now similarly, you should draw like this. Yes, very clear observed here. From graph, we are observing here. This is also known as floor function or step function. That's all. Okay, now some important points we will discuss now from definition. Okay, in which first one is observing everyone. Remember, for solving problems. Okay, now first one is step x is equal to x for x belongs to z. and step x plus step minus x is always 0 for x belongs to z. For example, x is equal to 2, step 2 plus step minus 2, step 2 value 2, step minus 2 value minus 2, 2 minus 2 0, like this. So always step x plus step minus x value 0 for x belongs to z. And one more point observe, step x plus step minus x is equal to minus 1 for x does not belongs to z. When x is non-integer, then step x plus step minus x always minus 1. Observing here, for example, step 2.5 plus step minus 2.5. Step 2.5 value 2 plus step of minus 2.5 minus 3, very clear, minus 1. That's always true. Step x plus step minus x value minus 1 when x is non-integer. And one more point observing here, this is very useful form. Step x is greater than or equal to n. If step x value greater than or equal to n, then x is greater than or equal to n where n belongs to z. This is very useful for solving the equations. Step x is greater than or equal to n, x is greater than or equal to n. For example, here for step x is greater than or equal to 3. Then what about x values? What about x range? So now how to write? Here, very simple. X value is what? Greater than or equal to 3. That means what here? X belongs to left close, right open, 3 comma infinity. Okay. Now one more point I will give. That is if step x is greater than n, step x is greater than n, then x is greater than or equal to n plus 1. Okay, and one more is if step x is less than or equal to n, less than or equal to n, then x is strictly less than n plus 1. For example, here for step x is less than or equal to 2, then what about x values? Very clear, x belongs to open interval minus infinity comma 2 plus 1, 3. Okay, this is the basic concept of greatest integer function or step function. Okay, applications we will discuss in the next video. Thanks a lot watching my videos. Namaste.